Hello students, welcome you all back to my channel Khan's Commerce Tutorial. So presently we are doing the subject Business Statistics 2, in which already we have started the topic Theoretical Distribution. So previous video we have completed the first part of Theoretical Distribution, that is binomial distribution. So in the video, in that theory video, we have discussed the meaning of the term Theoretical Distribution, then what are the different methods of Theoretical Distribution, Discrete probability distribution and continuous probability distribution. So the different methods what we have to study in this theoretical distribution are binomial distribution, Poisson distribution and normal distribution. So these three distribution we are going to study and we are going to solve the problems. The first part, binomial distribution, we have already completed in the previous video. Now in this video I am starting the topic Poisson distribution. So before watching the video, have a hard copy of the problems which I am providing in the link under description. So I expect that all the viewers, all the students who are watching this video get a hard copy of all the problems as well as one table I have provided for Poisson distribution, and that table, keep it ready before solving the problem. Now we'll discuss the meaning of the term this Poisson distribution. The Poisson distribution is also one of the discrete probability distribution, just like a binomial probability distribution. So this Poisson distribution is widely used in statistical work. It was originated by French mathematician Simon Denis Poisson in 1837. Strictly speaking, this Poisson distribution is a limiting factor of binomial distribution when n becomes large and p becomes very small. When p means the probability of success, the probability of happening of an event, which we call it as success. So the value of p is very small and the number of trials n is very large. In that case, it will be difficult to apply binomial distribution. So in that case, in those situations, Poisson distribution is most suited. So these events where the happening of the particular event is very small, probability of happening of the event is very small, these are called rare events. That's why this Poisson distribution is called probability of rare events. Rare events. But these situations may arise very frequently in real practice. Example where this Poisson distribution can be applied for rare events are the printing mistakes in books published. For example, a voluminous book is there, huge volume. In that, what is the probability of a mistake occurring in that huge book? So we have more number of pages, a voluminous book, but the probability of mistake is very small. So we apply Poisson distribution. Similarly, in a manufacturing organization, what is the probability of defective part? Suppose strict quality control techniques are applied. The defects are very rare. So in that case, we apply Poisson distribution to find out the probability of defective item. Similarly, in case of road accidents, suppose well-maintained roads are there, traffic regulations are fully regulated, rules are fully regulated. In that case, the possibility of accident is very small. So in this type of situation where the probability, the possibility of happening of the event is very small and the trials are more, there we apply Poisson distribution. So under Poisson distribution, the main parameter is m, small m, and m is equal to n into p. When we multiply n into p, we'll get the average. So m, small m, is the average event. So main parameter in Poisson distribution is m. So what is the probability function? What is the formula in Poisson distribution? The probability function of Poisson distribution is P of r is equal to e to the power of minus m into m to the power of r by r factorial. Just like what we have done in binomial distribution. In binomial distribution, we have P of r is equal to NCR, P to the power of r, Q to the power of n minus r. This was the formula already we have applied in binomial distribution to find out the probability of r successes in n events, in n trials. Same situation, same type of problem. Problems will be very much similar, binomial and Poisson. The only thing is here n will be large and the value of p is very small. So the formula for calculating probability of r success e to the power of minus m into m to the power of r by r factorial, where m is equal to n into p. That is the main parameter, right? Now what is this e? Exponential factor. This e we can get it from the table. There is a table, exponential, that is a Poisson distribution table. This is the Poisson distribution table. And you can get this table in any textbook, and also on Google you can get this table, or I'm providing this table in the link also. So keep it ready, this table. This table is Poisson distribution for e to the power of minus m for computing Poisson distribution. E to the power of minus m for computing Poisson distribution. This is the table which we use for calculating e to the power of minus m, right? Now, characteristic features of Poisson distribution. The first characteristic feature is it's a discrete probability distribution where the value of the variables are whole numbers. The variables are all whole numbers, no fractions are used, just like a binomial distribution. In a r ka value, p of r, the r value may be, all the r values will be whole numbers, there won't be any fractions. Then p very small and n is very large. One of the characteristic feature of Poisson distribution is the value of n, number of trials will be more, whereas p, probability of success, the probability of happening of the event is very, very small. Then third one, main parameter is m, and m is equal to n into p. In some problems, the value of m is directly given, whereas in some problems m will not be given, n and p are given. So we multiply n into p to get m. Only after getting m, we can substitute in the formula to find out the required probability. Mean is equal to m, variance is equal to m under root. Then very good model for determining probability associated with random variables like number of defects in manufactured parts, number of accidents, etc. In these cases of rare events, this Poisson distribution is much suited. So this is the only theory about Poisson distribution. The procedure, the formulas are similar. And in most of the cases, the mathematicians have given a rule, a broad rule, that this Poisson distribution is the good approximation of binomial distribution when n is greater than or equal to 20. Normally they have given a rule, एक broad rule दे दिए कि Poisson distribution कब suitable रहेगा जब n का value greater than or equal to 20 होगा या p का value less than or equal to 0.05 रहेगा. तो small p का value 0.05 और less रहेगा और n 20 या more than 20 रहेगा, तो in that case this Poisson distribution is very, very good approximation of binomial distribution. क्योंकि जब n large अगर p small रहेगा तो it will be very, very difficult to apply binomial. Binomial distribution का पूरा formula apply करना बहुत difficult हो जाएगा when n becomes large and p is small. In that case, Poisson distribution is the best alternative. This is the complete theory. Now we'll start the problems on Poisson distribution. Hope you have the copy of the problems in your hand. So before watching the video, keep it ready, the problems. First problem I am reading out. 2% of a given lot of manufactured parts are defective. Find the probability that in a sample of 100 items, none will be defective, exactly 2 will be defective. The contents of the problems are very much similar to binomial. The only thing is 2% of a given lot of items are defective. So we take P is equal to probability of defective part. The probability of defective part is only 2%. 2% का मतलब 2 by 100, 0.02. This is the probability of defective. And how many parts are there? Sample size is 100. So n is equal to 100. तो n का value बहुत बड़ा है और p का value बहुत छोटा है. तो this is the best, problem for apply Poisson distribution. So Poisson distribution we can apply. So what is the probability? None will be defective. That means R is equal to 0. R is equal to 0. Secondly, exactly 2 will be defective. R is equal to 2. Now, the procedure is similar to binomial. Now see here. Problems of Poisson distribution. P is equal to probability of defective part. 2% given in the problem. 0.02. 2 divided by 100, you will get 0.02. Total number of items are 100. So M, the main parameter in Poisson distribution is M. So M is equal to N into P. 100 into 0.02 is 2. So M is 2. We got M, 2. Since P is very small and N is very large, so we apply Poisson distribution. According to Poisson, the probability of R successes is P of R is equal to e to the power of minus M into M to the power of R divided by R factorial. The formula we are going to apply. First time we are going to apply the formula for Poisson. Now we substitute P of R is equal to e to the power of minus M. How much M we got? 2. So e to the power of minus 2 into M to the power of R. What is M here? 2. 2 to the power of R divided by R factorial. तो सिर्फ कुछ भी R का वैल्यू सब्स्टिट्यूट कर दो, आपको प्रोबेबिलिटी आ जाएगा. Whatever value of R you take, you will get the probability of that R. Right? Now probability that none will be defective. Two questions are asked. The first question, what is the probability that none will be defective? And 100 items में से total number of items are 100. एक भी defective नहीं रहना. तो what is the probability? तो probability that none will be defective, that is R is equal to 0. So in this formula, I am substituting 0 in place of R. So P of 0 is equal to e to the power of minus 2 into 2 to the power of 0 divided by 0 factorial. That is e to the power of minus 2 into 2 to the power of 0. Anything raised to the power of 0 will be equal to 1. Already we have discussed this in binomial also. So 2 to the power of 0 is 1. And 0 factorial will also be equal to 1. So e to the power of minus 2. Ultimately e to the power of minus 2 into 1 divided by 1 means e to the power of minus 2. Now we need what is the value of e to the power of minus 2. In some problems, e to the power of minus m value will be given. In other problems, it is not given. When it is not given, you have to refer the table. Refer the table. In this table, you have two parts. The upper part is a large part, big part, whereas below it a small part, small table is there. The first table a large table, second table a small table. The small table will be used for whole number. When m value is in whole number, we refer the small table, small lower table, right? When m value is in fraction, we refer the upper table, large table. अगर फॉर एग्जाम्पल यहाँ पर m is equal to 2.5 अगर रहता तो we would have consulted the first large table. यहाँ पर whole number है तो below small table. So in the small table you can see m 1 2 3 4 5 6 up to 10 and e to the power of minus m. So e to the power of minus m under 1 we have 0.36788. Under 2 we have 0.13534. Under 3 you will have 0.04979. All the values are given under 1, 2, 3, 4. Right? So हमारे पास what we are having e to the power of minus 2. E to the power of minus 2. So e to the power of minus 2 we have 0.13534. From the table you can have 0.13534. If you don't have the table, you can go to Google Net. In Google, you can type for this Poisson distribution table. You can get the table, you can refer the table there also. So here, e to the power of minus 2, from the table we are having 0.13534. Therefore, probability that none will be defective is 0.135. 13534 पूरे 5 डिजिट लो डेसिमल के बाद या 3 डिजिट ले लो 135. So ultimately we got the probability that none will be defective is 0.135. Similarly, probability that exactly 2 will be defective. Probability that exactly 2 will be defective. पूरे 100 में से 2 आइटम डिफेक्टिव होना उसकी probability क्या है? तो R is equal to 2. R is equal to 2. तो e to the power P of 2 is equal to e to the power of minus 2 into 2 to the power of 2. M to the power of R है. M भी 2 है और R भी 2 है. तो e to the power of minus 2 into 2 to the power of 2 divided by 2 factorial R factorial. ये फॉर्मूला में सब्स्टिट्यूट करूंगा. P of R is equal to e to the power of minus 2 into 2 to the power of R by R factorial. Now in place of R I am taking 2. तो जहां पर भी R है वहां पर 2 लूंगा. 2 to the power of r है 2 to the power of 2 और r factorial है 2 factorial, right? E to the power of minus 2, just now we have referred the table 0.13534 into 2 2s are 4 divided by 2 factorial 2 into 1. 2 factorial means 2 into 1. अब multiply करें 0.13534 into 4 divided by 2, you are going to get 0.27068. 0.27068. So probability that exactly two parts are defective is 0.27. 27% chance है कि items may become defective, may be defective. That's all. This is the first problem. Now see the second problem. It is known from past experience that in a certain plant there are on an average 4 industrial accidents per year. So directly average is given. In this problem directly average is given. Previous problem average was not given, so we have multiplied n into p. ये multiply करके m मालूम करें. लेकिन अब second problem में average is directly given in the problem. So on an average 4 industrial accidents per year. तो एक फैक्ट्री में, एक प्लांट में एक्सपीरियंस के हिसाब से ये कि 1 year, in 1 year 4 accidents are taking place. Find the probability that in a given year there will be less than 4 accidents. Less than 4, 4 से कम. तो 4 से कम क्या हो सकते हैं? 0, 1, 2, 3. लेस देन 4 बोल रहा, 4 को नहीं मिलाना है, 4 से कम होना है. तो 4 से कम क्या क्या वैल्यूज रहेंगे? 0, 1, 2, 3. So we have to find out what is the probability of 0 accidents. No accidents at all. No accidents. Probability of 1 accident. Probability of 2. Probability of 3. Right? Now see. M is equal to average number of accidents per year. It is given in the problem average 4. M is equal to 4. E to the power of minus m is equal to e to the power of minus 4. M value we got 4. M value we got 4. So e to the power of minus 4 is equal to 0.0183 given. I told you in some problems e to the power of minus m value will be given in the problem itself. In that case no need to refer the table. No worry at all. Because in the problem itself it will be given. So ये problem है, second problem है, it is given in the problem that e to the power of minus 4 is equal to 0.0183. That's why I have written here given in the problem. Now according to Poisson distribution, P of r is e to the power of minus m into m to the power of r by r factorial, same formula. The probability that in a given year there will be less than 4 accidents. We have to find out what is the probability that in a given year less than 4 accidents will take place. Less than 4 का मतलब 0, 1, 2, 3. So P of r less than 4. Less than 4 is equal to P of 0 plus P of 1 plus P of 2 plus P of 3. P of 4 को नहीं मिलाएंगे. हाँ, equal to and less than अगर रहता तो 4 को include करते थे. Less than and equal to अगर रहता तो यहाँ पर less than equal to लाए. But in the problem it is saying less than 4. Less than 4 का मतलब only 3. So 0, 1, 2, 3. So P of 0. First we calculate P of 0. P of 0 is equal to e to the power of minus 4 into 4 to the power of 0 by 0 factorial. 4 to the power of 0 is 1. And 0 factorial means 1. When you multiply anything with 1, you will get the same value. 4 into 1, 4. 5 into 1, 5. तो कोई भी वैल्यू को 1 से मल्टीप्लाई करें तो सेम आएगा. उसी तरह e to the power of minus 4 into 1 is e to the power of minus 4 only. Divide by 1, same value will get. So e to the power of minus 4 value is here 0.0183. तो एक वैल्यू आ गया p of 0 is equal to 0.0183. Now p of 1, p of 0 आ गया. अब p of 1 तो e to the power of minus 4 into 4 to the power of 1 divided by 1 factorial. ये r है. e to the power m to the power of r by r factorial. तो e to the power of minus 4 का वैल्यू already we have 0.0183 into 4 to the power of 1 is 4 and 1 factorial is 1. So now multiply 0.0183 into 4, you get p of 1 0.0732. So we got p of 1. Now p of 2. P of 2 is equal to e to the power of minus 4 into 4 to the power of 2 divided by 2 factorial. r की जगह पर ये फॉर्मूले में जहां पर भी r है वहां पर 2 ले लेंगे. तो 4 to the power of 2, right? तो e to the power of minus 4 is 0.0183. 4 to the power of 2, 4 4 is 16, 2 factorial, 2 into 1, 2. So P of 2 we got 0.1464. Similarly P of 3, e to the power of minus 4 into 4 to the power of 3. E to the power of minus 4 into 4 to the power of 3 divided by 3 factorial. So e to the power of minus 4, 0.0183. 4 is multiplied 3 times. 4 into 4 into 4. 4 4 is 16, 16 4 is 64. 3 factorial, 3 into 2 into 1, 6. Now you simplify, P of 3 is 0.1952. So we got P of 0, P of 1, P of 2, P of 3. All the 4 items we got. Therefore, probability of less than 4 accidents per year is P of 0 plus P of 1 plus P of 2 plus P of 3. ये 4 values, P of 0, P of 1, P of 2, P of 3. पूरों को add कर लो, 0.4331. तो final answer, probability that less than 4 items, less than 4 accidents taking place in a year is 0.4331. That's all. So in this video, I have explained to you the meaning of the term Poisson distribution, what are the characteristic features of Poisson distribution, and what is the function, probability function of Poisson distribution, right? Then 2 problems we have solved. The problems are very simple, just like a binomial, we have the formula, right? The only difference is we have to refer the table. In most of the problem, in the problem itself, the value of e to the power of minus m will be given, most of the problems. In some problems, it may not be given. In that case, you have to refer the table. Poisson distribution table. The table is called Poisson distribution table. So you can get it from any textbook or from Google. Okay. So we'll continue in the next video. We have completed 2 problems.